In this example, we will determine whether a relation is a function. Recall a function is a relationship between the input and the output. And in a function, there is exactly one output, in other words, y value, for each input. So a function is a relation, again, in which each element of the domain is paired with exactly one element of the range. In other words, to put it in plain English, you cannot have two of the same x values. As soon as you notice that your x values repeat themselves, then it is not a function because it will fail the vertical line test. If you were to graph it, you would see that it would fail that test. So here, all you need to do is just take a look at your x values and ask yourself, does any of them repeat themselves? And as we can see here, yes, they do. So therefore, this is not a function because each x values must correspond to exactly one y value. And here we see that 3 is assigned to two different y values. So therefore, it is, again, not a function. In this example, we want to determine whether a graph is or is not a function. So we defined functions earlier. Remember, with a function, it is to where it's a relationship, in other words, between the input and the output, where each element of the domain is paired with exactly one element of the range. If you have a graph, you can do what is called a vertical line test, which is to draw an imaginary vertical line through your graph, and if it touches in exactly and only one point, then that defines that graph as a function. However, if that line, vertical line drawn, touches in more than one point, then it is not a function. So in this example, we wanted to determine which one of these is the graph of a function. In other words, of all of these graphs, they will all fail the vertical line test. There's only one here that will pass the vertical line test and only touch in one spot, and that is the graph of C.